Bubble sorting. It is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. That is, if we give some elements in wrong order, it will correct it or it will arrange it in the right order, that is ascending or descending order. Now, let us consider an example. Consider the elements 5, 1, 4, 2, 8. These are the elements to be sorted. So now we give them the array number, that is, we give them the place, which is 0, 1, 2, 3, 4. There is A of 0, A of 1, A of 2, A of 3, A of 4. As we know, array stores homogeneous data types. So it is like a storage element array. So this is A of 5. Now n is equal to 5, which is the total number of elements. So before going into the actual program, we have to understand some things. That is, when I is equal to 0, sorting of the first element takes place. When I is equal to 1, sorting of the second element takes place. And when I is equal to 2, sorting of the third element takes place. And when I is equal to 3, sorting of the fourth element takes place. Now let us go to the program, main program, or the basic of the program. That is, for every program related to arrays, we use for loops, because we use a for format because we need to repeat the loops sometimes, or most of the time we have to repeat the loops. So we use for. So here, for I is equal to 0, I less than n minus 1, I plus plus means n, as we know, it's the total number of elements, that is n is equal to 5. N minus 1 means 4. So I less than 4 means 3, which is when the condition reaches this. Till the condition reaches I is equal to 3, the loop or the inner loop has to execute whatever condition is inside. So here we have written for I is equal to 0, I less than n minus 1, I plus plus. Again we open the loop. Again for j is equal to 0, j less than n minus 1, j plus plus. So here some of you may have doubt, what is I and j? I means the number of passes, that I will explain to you in the example, and j means the number of times swapping happens. That is, here the swapping takes place 4 times, that is I is equal to 0, I equal to 1, I equal to 2, I equal to 3. So it happens 4 times. That's why we have given when j is equal to 0, j less than n minus 1. Again when j less than 3, j plus plus. That is, till j reaches 3, it has to continue whatever condition it's given. So the condition is if ARR of j is greater than ARR of j plus 1. That is, the element stored in ARR of j is greater than ARR of j plus 1. Swapping has to take place. How swapping is done is that temp is equal to ARR of j. That is, we assign the first element, or we assign ARR of j to a temporary value temp, and ARR of j is equal to ARR of j plus 1. That is, we compare them, and ARR of j plus 1 is moved to temp. So this is the basic swapping principle. That is, temp is equal to ARR of j, ARR of j is equal to ARR of j plus 1, and ARR of j plus 1 is equal to temp. So this is the basic swapping principle. Now let us go to the example. Consider these two elements. As we know, bubble sorting works by comparing the adjacent elements. That is, only the adjacent elements is compared. So comparing these, we know that 5 is greater than 1. So we have to swap them. So we get 1, 5. And the rest of the elements are written as such since we compare the adjacent elements. So 4, 2, 8. Again, we consider the next two elements, 5 and 4. Here, as we have seen again, 5 is greater than 4. So the order is wrong. Again, we have to swap them. So now the order is 1, 4, 5, 2, 8. Again, for the next swapping, we need to compare the next two elements, which is 5 and 2. Again, 5 is greater than 2. So we have to swap them. So now we have swapped them. Next, we have to compare the last two elements, which is 5 and 8. Now 5 is less than 8, so no swapping is needed since it is in the correct order. So we have to write it as such, which is 1, 4, 2, 5, 8. Now this is 4, I is equal to 0. That is, this is the first iteration, that is, or this is the first pass. Now, as we have seen, the first number and the first element and last element are sorted properly. That's the peculiarity of the first pass. At least the last element will be placed in order at the first pass itself. Now we have to see when I is equal to 1. So now we have to consider the last order, the last format. We have to write the last format, which is 1, 4, 2, 5, 8. Again we compare the adjacent elements. So we compare the first two adjacent elements, and as we know 1 is less than 4, so no swapping is needed, so we have to write it as such: 1, 4, 2, 5, 8. And now we compare the next two elements, which is 4 and 2. Here the order is wrong, so we have to swap them. So we write 1, 2, 4, 5, 8. Now we compare the next two elements, which is 4 and 5. Now it is in order, so that is 4 is less than 5. So again we have to write it as such: 1, 2, 4, 5, 8. Again we have to compare the last two elements, and it is in the right order, that is 5 is less than 8. So swapping is not needed. So we write it as such: 1, 2, 4, 5, 8. So now it is in ascending order, which is 1, 2, 4, 5, 8. It is in the right order, but the condition is not finished, because so now our algorithm does not know if it is completed. Even though it's in the right order, the algorithm doesn't know it is completed. So the algorithm needs one whole pass without any swapping to know it is sorted. So what we have to do is, again we compare them, and we make sure that there is no need of swapping, or it is in the right order. So we write one whole new pass. So now we have the third pass where no swapping is done. That is, 1 and 4 is compared, no swapping is needed, so we write it as such. Again 4 and 2 are compared, no swapping is needed, so we write it as such. Again 2 and 5 are compared, it's written, and 5 and 8 are compared, so no swapping is needed. Now the algorithm is complete. We come to the program of bubble sorting. So first we write the format #include stdio.h and void main. Void main is used to actually link the program, or link the C library to the program, because we use some function like int, printf, scanf, etc., which are already defined in the C library. So opening the brackets, we declare the items, which is int n I j temp a of 50k. So n represents the total number of elements, I represents the iteration, j means the number of swappings, temp is where we store the temporary value, a of 50 means the size allocated for the elements. Since we consider integers or decimal numbers, we allocate size a of 50, and k is a constant. So next, printf, enter the number of elements. So printf, the main function of printf is whatever we give inside it will be displayed in the monitor, displayed in the output. Now scanf, inside quotes %d ampersand n. Now scanf, it reads whatever is given to it, and %d means, since we give the input as numbers, since the inputs are numbers, we use %d. And if the input is string, we use %s. If the input is character, we use %c, etc. So it's just the format. So %d ampersand n. So ampersand is to be used only inside scanf. Ampersand should be used. So enter the number of elements. We gave ampersand n. So next, printf, enter the elements. Now we reach the program. For I is equal to 0, I less than n, I plus plus. Now inside the quotes, scanf %d ampersand a of I, that is, it reads the array of elements, or it reads the array of pass. Now for I equal to 1, I less than n, I plus plus. For j is equal to 0, j less than n, j plus plus. Again for j is equal to 1, j less than n, j plus plus. Now these now this part is same as that of that I have explained in the example. Now after that, if a of j is greater than a of j plus 1, as we have discussed there, this is the basic part of the program. So inside the loop, temp is equal to a of j, that is we assign a of j to temp, a of j is equal to a of j plus 1, a of j plus 1 is equal to temp. Simple steps. Again, closing the loop, closing the bracket, we come print f percentage n after pass percentage d, that is after pass print I. Now for k is equal to 0, k less than n, k plus plus, print f percentage d a of k. So what this a of k represents is the final order, or the order which is the elements which are arranged in order. That's what this a of k represents. So finally, when we give printf percentage d or a of k, the ordered elements are presented on the monitor, presented on the screen. So that's it about bubble sorting. Hope you understood.